What did one emo fan say to the other emo fan? I'm a big metal fan. Yeah. Okay. That's enough. So we've got trig equations. This is going to be a fairly chunky topic. It's not going to be too bad, but there's a lot of things that you kind of need to understand. So I'm going to try and break it into two parts. So for the first part today, all you're going to do is you're going to solve trig equations. And generally, you will need to know things like your quadrants, all stations to central, all centrals to station, all stations to central, related angles, the acute related angles in particular. Things like your trig graphs and your trig identities, all this stuff you'll kind of need to know. And they help you to solve these equations. That's why we did all those stuff before. Now, general tips. Okay, I can't stress this enough. Understand your trig graphs. Know what sine x looks like, tan x looks like, cosine x looks like, and know how to sketch it between 0 and 360 and potentially towards the left, maybe like from 180 or whatever. Like understand your trig graphs. They are paramount in not dropping any mistakes here. Okay. Now, the first one we're going to look at is the standard trig equation generally. Okay, not all the time, but the general standard trig equations, they have this domain between 0 and 360. Okay, so they'll say solve for x in between 0 and 360, and they'll say something like, this is your equation, cos x equals to 1 on root 2. Okay, now I've written here on the side, these are the steps I'm thinking through to try and solve this. Okay, generally what happens if I'm trying to solve is first things first, I'll find the acute positive angle, which means it's the first quadrant angle. I'll note which quadrants have solutions because cos x is either positive or negative or potentially both. And then the last one is you're going to find all your correct related angles within your given domain. Okay, I'm going to do a couple examples here, so hopefully you catch it as we go. I'm going to do this in maybe, yeah, I'll just go black. Okay, so first things first, let's solve for the acute angle, which in other words is always positive. So if cos x equals to 1 on root 2, I could either do this in my calculator, or I could recognize that 1 on root 2 is an exact value. I know for a fact it is 45 degrees. Okay, so that there, I've used the positive value here. Sorry, that was horrible. I've used the positive value and now I've solved that my angle is 45 degrees. Now the next part here is, unfortunately, I'm not done. I've only found one of my potential many solutions. So now I need to take a look. I need to note which quadrants have solutions. So I'm looking between 0 and 360. So 0 and 360. So that means I'm looking across one full rotation of this all stations to central. And I've noticed here that cosine x is either positive or negative. And in this case, 1 on root 2 is positive. So cos, in this case, cos is pos. Okay, so what I mean by that is if I take a look at my all stations to central, I can see that where cos is positive is in the first quadrant and in the fourth quadrant. So all I need to do here is, let's find my first quadrant. My first quadrant answer I've already found. 45 degrees is in between 0 and 90, so that's my first quadrant answer. I found it. And the other one I'm looking for is I'm looking for the fourth quadrant. And how do I find my fourth quadrant answer? Hopefully you remember, if that was theta, this was 180 minus theta, this was 180 plus theta, and the last quadrant was 360 minus. So I'm going to go 360 minus 45. That's how I find that. That becomes 315. So therefore, my solution for this one is x equals to 45 and 315. There's two solutions. I'd need both to be correct. Hopefully that's making sense. Okay, just in case we've forgotten, let's try to run another one. And this time I've got something slightly different. I've got tan x equals to -1 on root 3. So my first step again is to, what was my first step? Solve for the acute angle, which is positive. So in other words, for the first part here, I'm going to say tan x equals to 1 on root 3, and I'm not going to worry about my negative. Okay, I'll use the negative to help me out later. And hopefully if I do this, it should give me an exact answer. Regardless, if not, I'm pretty sure 110. Should have planned this earlier. This is 30, 60. So if it's 1 on root 3, it'll be x will equal to 60. Okay, you can just use your calculator. You can use your exact. If anybody caught that, I'll give you a merit. It should be tan 30 because that would be my opposite over adjacent. So that's that. Cool, so x will equal to 30. Now I found my first quadrant answer. This is my first quadrant acute answer, it's 30 degrees. Once I've done that, let's figure out where my solution should actually go. My solution should actually go all stations to central. Now I'm taking a look at this from this equation, tan x is negative. So I'm going to take a look. Where is tan negative? Well, it must be negative in the second quadrant, and it must be negative in the fourth, because in A and T, all is positive in the first, tan is positive in the third, but I've got here tan x is negative. So now I'm trying to find all my related angles. So in other words, I want my second quadrant. And how do I find my second quadrant? It's 180 minus my first quadrant. And my fourth quadrant again is going to be a 360 minus my original. And so that gives me 150 degrees and 330 degrees. And just take a note here. Both of these answers sit within our domain. Whoops. They sit between the 0 and 360 that we were originally talking about. Okay, so these ones, that's your two solutions, and you just say, therefore, x equals to 150 degrees and 330 degrees. If you are completely unsure, go back to your actual equation and type in tan 150 and type in tan 330. It should give you the exact same thing as whatever the value of negative 1 on root 3 is. Okay, that's a good way to check. Substitute your answer back in and show that the left-hand side equals the right-hand side. All right, thanks for bearing with me. I think there's one more, and this one shouldn't take as long. There's going to be some equations where you have, it's called boundary angles. That's what they call it. Boundary angles are simply the angles of 0, 90, 180, 270, 360. So if we're talking about our all stations to central, it's kind of like the corner ones, 0, 90, 180, 270, 360. And these ones here, you can't really solve, there's no related angle. And so what we do here is we actually just do it by graph. Okay, so we understand the graph, we kind of read the answers off it. Okay, usually the answers that you'll notice that there's boundary angles is if you have things like something equals to -1 or something equals to 1 or something equals to 0. That's how you'll generally have a hint. It is a boundary angle. Now, I'm solving between 0 and 360. I'm solving for sine x equals to 0. So the thing I'm going to do is I'm going to sketch from 0 to 360. And this is my sine x, not great, but good enough. I know it peaks at 1. I know it dips at -1. And I know it's going to equal 0 at 3 particular spots. And so between 0 and 360, when does sine x equal to 0? Well, hopefully you guys remember this graph. If not, go back and look over these. But in this case here, you can see the values of x for where my graph is 0 is going to be 0, 180, and 360. Okay, that's it. I've drawn my graph and I'm just reading the answers off it, seeing where sine x equals to 0. And what about when cos x equals to 0? I'm going to do something similar here. I'm going to draw cos x. And I'm going to say, okay, that's roughly 360. That's roughly 180. And so this is actually going to be 90 and 270. If I drew it kind of correctly. So you can see here, for this one between 0 and 360, my solutions are 90, because that's where it equals 0, and 270, because that's the second time that the graph equals 0. Hopefully that made a little bit of sense. I'll catch you guys later. All right, bye.